What we're starting today is Chapter 8. Chapter 8 is similarity. We're talking about similar figures. And the first thing we're going to look at is corresponding parts of similar polygons. In the diagram below, triangle ABC is similar to triangle DEF. You can write this, ABC is similar to DEF. So we have our one kind of little squiggle line. We did this with our congruency, but we had an equal sign underneath it to say they're congruent. They are the same shape. So we use just one. We're talking about the two being similar. They're not the exact same, but they are similar in size, either bigger or smaller. A similarity transformation preserves angle measures, so corresponding angles are congruent. A similar transformation also enlarges or reduces the side lengths by a scale factor. So all the sides are increased or decreased by the same. Right across. So all the side lengths are either increased or decreased by what we call a scale factor, so the same amount. All the corresponding angles are going to be congruent, and the sides are proportional. Water. So if we take the sides from what we're going to, so DE over AB, EF over BC, and FD over CA, we get this same scale, this scale factor. So we want to look at this here. So we're told that these two triangles are similar. So we want to find the scale factor going from RST to XYZ. So we're going to find that. We're also going to list the corresponding pairs of congruent angles, and then our proportions for sides. Thank you. So we look at this here, RST, XYZ. Now we could go ABC, but let's find all the pairs of congruent angles first. And again, just like with congruency, they're going to match up. So if we start with R and X first, they are actually going to be congruent. So one of our pair of congruent angles is that R is congruent to angle X. Then we went to S is going to be congruent to Y. And lastly, angle T is going to be congruent to angle So just like with our congruency statements, the similarity statements, the angles are going to line up. Any questions on how we found the congruent angles? Now the corresponding sides are going to match up too. Highlighter. So RS is going to match up to which side? XY. What side is going to match up to ST? ZY. And lastly, ST would match up, or STR would match up with ZX. Okay, so we have the sides that match up, and we can see these here, yes? Now the question is, with the proportionality statement, where are we going from what to what? We're going from RST to XYZ, yes? We're going from 20 to 12. Is the number getting bigger or smaller? Smaller, so should the bigger or smaller number be on top? So if we're going from bigger to smaller, what we're multiplying 20 by should make it smaller, yes? So the smaller number should be on top. So we write our proportionality statements. The side length with the smaller side should be on top. So which one set aside could we start with? So 12 over 20, so 12 is what? Over RS. XY over RS. So we're wanting the statement. So XY over RS is equal to, so we need another set of sides from the small. So ZY is going to be over ES or ST, either way. And that leaves the last one, XZ or ZX over TR or RT. And when we think of scale factor in this here, one way we can think of it is as new over old. New over old. Because where are we going from and where are we going to? So we're coming from RST. RST would be the old. The new, what we're going to is X, Y, Z. Any questions on this so far? And we finished this problem here. No, we still need to find the scale factor, and we denote it as little k. Now, we could pick any of the side lengths and do their proportion. So as we were going to do earlier, so 12 over 20 would be one of them. Will this reduce? Six over 10, does that reduce? Does that reduce? Well, there's no more common factor, so 3 of 5 is reduced. So the scale factor should be 3/5. And if we wanted to check that, we could, because we could say 18 over what? 18 over 30. And in a calculator, I could do 18 over 30. And is that what we got previously? And if we look at the last two sets of sides, is 15 over 25, which is 3/5 as well, yes? And again, the scale factor is what we're multiplying the first one by to get to our other lengths. So if we multiply 25 by 3/5, so if I say 25 times 3/5, what should we get? What's the side that matches up to it? Let's see what we get. 15, we get that length. So the scale factor for this is 3/5. These are our three congruent angles. And this is our statement of proportionality, or the ratio of the corresponding side lengths in a statement of proportionality. Questions on any of this here? We're going to look at another one. Got this here. In the diagram, ABC is similar to JKL. And out of these three, so we're going to find the scale factor. So we're going to find our value of K. We're going to find all pairs of congruent angles. And since we're talking about triangles, we should have 3. And our proportionality statement of the side lengths, which we should have 3 fractions. Which one do we want to start with first? C. So, ABC, so we start off with AB would match up to which side? JK. BC would match up with KL. And lastly, AC and JL. And we could use that there to write our proportionality statement. Now again, proportionality statement is new over old. So we're going from where to where? So ABC to JKL, yes? So the new side, one of the new sides would be on JKL, yes? So one of them would be what? JL. We just need to pick one, right? Now, what side matches up to JL? AC. Okay, what's another set of sides? So KL on top and BC. And lastly, AJ on top and BA on bottom, or AB. So any of these that we do have listed, we could have the flip of them as well. So we could have JLLJ over AC or CA. And we have these here. Any questions on the proportionality statement? And I know we're doing these in a little bit backwards order, but sometimes finding one of them is easier than finding the others. Now the list of congruent angles. So we have angle what? Angle A is congruent to angle J. Angle congruent to angle K. And lastly, angle C is congruent to angle L. And again, that'll match up with our statements, A and J, B and K, C and L. Now the last thing we need to find is our scale factor. So new over old. So it's one of our new side lengths. So it'd be one of 36 over 27. Now we need to simplify this. So we can do this in a calculator. Let's try this one more time. 36 over 27 is so 4/3, 1 1/3. We can leave it as 4/3. And does 4/3 make sense? Are the side lengths getting bigger? So the scale factor should be greater than 1. What would happen if the scale factor was 1? It'd be the same, right? Because we multiply by the scale factor. Scale factor of 1 is not changing the size. Questions on this here? Yes. So I just picked 36 over. No, so let's try 48 over 36. So we could do this here. Now, 48 over 36, we're going to use a calculator, is 4/3. Yes. That's actually a good question. I'll have to look that up and see. And we do use scale factors in a lot of different places. Maps have a scale telling us what the measurement or the graph is. If you've dealt with models, where they tell you the model is 1 to 40 scale inches. So that's just saying for the model, for every 1 inch on the model, in real life you have 40 inches. Or here we're saying for every 1 unit of this one here, we have 1 1/3 units here. And it's just our scale. Questions on this here? Questions on any of this so far? In the diagram, JKL is similar to PQR. Find the scale factor from JKL to PQR. So we want to find find the scale factor. We want to list all congruent angles and then write the ratio of the corresponding side lengths. So which one do we want to do first? Find the congruent angles. So we know angle what? Angle K. Angle K is congruent to angle Q. We know angle J is going to be congruent to angle P. And lastly, angle L and angle R are congruent. Now, sometimes this helps if we match up the sides. So JK would be matching up to which side? PQ. We also know that KL will match up to which side? QR. And lastly, JL, PR. So which side links are going to be on top? So we're going to, so new over old. So the new side links are coming from triangle PQR, yes? So one of the side links from it would be PQ. Now PQ matches up with which side? Yes, JK. Okay. What's another side link that would go on top? QR. And lastly, we need to find our scale factor. What over what? So we wanted 6 on top, yes? And what would be on bottom? Almost 4, which would be 3 over 2. Now, if we wanted to use the other 6, it'd be 9 over 6, which is indeed 3 over 2. So since we're wanting to go from JKL to PQR, since the side links are getting bigger, we need the scale factor to be greater than 1. Because even if we did 12 over 8, that's still 3 over 2, because they have a common factor of 4. 12 divided by 4 is 3. 8 divided by 4 is 2. So we get 3 halves. Again. Yes. Yeah, so it's where we're coming from. So new over old. New is where we're going to, old is where we're coming from. Because if we do 4 times 3 halves, we should be able to get to 6. So 4 times 3 halves does give us 6. And that's kind of what we're doing, where we're going to. So we should be able to say 6 times 3 halves gives us 9, and 8 times 3 halves gives us 12. Now, if we went the other way, we wouldn't multiply it by 3 halves. We would multiply it by 2/3. It just flips it. Questions on any of this here? Now, corresponding links in similar polygons. If 2 polygons are similar, then the ratio of any 2 corresponding links in the polygons is equal to the scale factor of the similar polygons. So if 2 polygons are similar, then their scale factors, as we've seen already, should be the same across all of them, yes? So if we look at this here, in the diagram, DEF is similar to MNP. Find the value of X. Well, it didn't ask for this, but I'm going to still do the corresponding sides. So what would be the corresponding side to ED? And M. And again, I would make sure that they do match up, because every now and then they can tend to be tricky, because DE and MN are the same. How about DF? NP. So EF and NP, yes? So that means the scale factor of 15 over 18 or 18 over 15 would be the same as 24 over 20 or 20 over 24, as well as our x over 30 or 30 over x, yes? So the scale factor, what we'd multiply to go from here to here, or vice versa should be the same, yes? And our proportionality statement is saying that EF over NP should be the same as the proportion to ED over MN, yes? Which would technically be the same as DF over MP. Now it seems a little weird that I chose these here, but I chose EF because what is EF's length? X, yes. And because again, for this problem here, we're solving for the value of X. And whenever we solve these here, I want X to be in the numerator. It's going to make it easier to work with. In P, its corresponding side is $30. NP. NP. So X over 30 is what we have, yes? So I chose ED, which is 15. And MN is 18. Did I have to pick 15 and 18? So what could we have picked besides that? 20 and 20. Yeah, 20 and 24. As long as I have two other sides that we have the values for. Now what do we need to do? We need to solve for the value of. How can we get X by itself? Multiply both sides by 30. And the reason we do this, I'm going to write this out so we can at least see it once. Because if we multiply X over 30 by 30, we multiply the 30 by just the numerator, which would be 30X over 30. The other side, we can multiply the top by 30, so we'd have 15 times 30 over 18. But 30 divided by 30 is 1, just leaving us with X. Now the other side, we have 15 times 30 over 18. 15 times 30 over 18 is and that's it. Questions on this here? And with that is 25, it does make some sense. Because if we're going from 18 to 15, we are decreasing. 30 to 25, we are decreasing, is getting smaller. Yes? And the reason I point this out is because if we got, say, 45 for X, would that make sense? Well, no, because we can't go from 30 to 45 and it decrease. And it should still contain this proportionality, because if we looked at 15 over 18, we can do this in a calculator, 15 over 18 is 5/6. 25 over 30, 25 over 30 is 5/6. And even though we didn't use this, 20 over 24 is also going to be 5/6. Questions over any of these here? So, let's look at this one here. So we're told that these two figures are similar. GHM is similar to HKL. Find the value of X. So we're going to set up a proportion. Now, the other way we can do it, and I'll show you this here in a minute. So one way we can do this is setting up a proportion. Now, one of the numbers in the numerator, I'm going to make X. One of the links I'm going to make be X, because it works out nicer that way. Now, what is the side length that corresponds with x? HM, which is 12. So we have x over 12 equals what over what? 27 over 18. We didn't have to pick 27. We could have picked 15, but it would have been over 10 instead of 18. Now what can we do next? Multiply both sides by 12. And as we just saw in the previous one, the 12 and 12 will simplify, yes, cancel out, leaving us with x. On the other side, we have 27 over 18 being multiplied with 12. Yep, we can do 27 over 18, parentheses 12. And we get 18. So the value of x is 18. Any questions on this here? Now, I want to look at another way to do this. So we're going from 12 to x, yes? Which means our scale would be the same as going from 18 to 27 or 10 to 15, yes? So the scale is getting bigger or smaller? 27 to 18. We're going bigger. Yeah, no, it is bigger. 18 to 27. We're getting bigger, yes? So the scale factor would be 27 over 18, yes? In the calculator, we can do 27 over 18, which is 3/2. So 18 times 3/2 should give us 27, yes? And we can check it. 18 times 3/2 is 27. If I do it with 10 times 3/2 should give us 15, yes? What was the other side length? 12, yes? Times 3/2 is, so the value of x is 18. Now this is the exact same thing we did, just in a different format. If I go back. So this here, 27 over 18. If we reduce this, is, so this here is the same as saying 3/2 times 12. It's just our scale factor. And we get the exact same thing. Any questions over any of this here? Find the altitude, the length of the altitude. Now the altitude of a triangle is its height. So the altitude of a triangle is a height. So it's one of the vertices to the other side that makes a right angle. So we want to find the altitude, the length of PS. Well, PS's length, what are we going to put it over? PS would be over what? So PS, its length, we can put it over 20, is equal to what over what? So x over 20, because the altitude of one over the altitude of the other would be similar to what? Or other lengths? 6 and 8. 6 was connected with x, so, and 20 is connected with 8. Now what can we do next? We can multiply both sides by 20. Here the 20 and 20 will simplify, giving us x is equal to, so we have 6 over 8 times 20 is, so our altitude of PS is in the diagram, UVW is similar to QRS. Find the length of median ST, so this length here, in this figure. So we can set up a proportion. So we'll have x over a length is equal to a length over a length. So what length is similar with length x? 12. Well, what number would we put on top? So we'd have 36 and 16, yes? Which side length is similar on the same triangle as x? So it's going to go on. And 16 is going on bottom. So x is connected with our QSR. So we need another length connected with QSR on top. Because where did we get 12 from? From down here, so we need one of the 16s from here. Now at this point here, we can multiply both sides by 12. These will cancel. And now we just need to simplify this over here. So we have 36 over 16 times 12, which is 27. Yes, sir. Yes. Any questions on this here so far? Now again, when we say something's proportional, we're saying that all the sides are increasing or decreasing by the same amount, yes? Now what was our side length with our x? It was our 36, yes? So we said the median over the side length. And over here, we're going to put the median over the side length, yes? Now we'll see here, so I kind of switched the setup because I said the median over its side length is equal to the median over its side length. Now let's see if we get the same thing, because here if I multiply both sides by 36 to get x by itself, these again would cancel. And this time we're doing 12 over 16 times 36, yes? And we get the same thing. Because in either case, the two numbers that are on top are both 12 and 36. So we end up getting the same thing. Because again, we're talking about proportionality, things being proportionate. So as long as we keep the proportionality the same, we should get the same amount. And this one here, I think we can do this one here and be done, or we'll finish this tomorrow. But I don't think we necessarily need to do the calculations for this one. Because where we're going from ABCD to QRST, yes? So, well, let's go the other way first. So if I go from 6 to 12, what am I doing? 5 to 10. 8 to 16 is times 2. So 4 to x would be, so x is, yeah. So sometimes the scale factor is nice and we can see it. So we're just multiplying everything by 2. Or if we're going in the other direction, we're dividing everything by 2. But we will pick this up from here tomorrow.